Hello everybody, my name is Haro. Welcome to this video series where we're solving Codeforces problems in Python. Today we're doing problem 320A, which is called magic numbers. It's a bit of a tricky problem, but again, there is a simple solution to it, especially if you're working with Python. Let's go ahead and see how we're solving this problem. Okay, so a magic number is a number formed by a concatenation of numbers 1, 14 and 144. We can use each of these numbers any number of times. That means it can be from 0 also to how many ever times we want. Each of these numbers 1, 14 and 144. Therefore 1, 4, 1, 4, 4, 14, 144, 1, 4, 14, 14, 14, 14, 1, 1 are magic numbers, but 1 and 3 fours right here. See, 144 is obviously a number here, but 4 is not a magic number. 5 is not a magic number. 14 is a magic number. 4 is not. They are not magic numbers. That's what they're trying to say. These are magic numbers. So given an integer, we have to find out whether they are a magic number or not. And that's the question we had. How do we solve this question? Okay. So what they're saying is a magic number can have the numbers 1, 14 and 144. Okay. And magic numbers, you can see, you can decode two things. Number one, doesn't start with 4. Right? Doesn't start with 4. Doesn't start with 4. And number 2, it only has 1 or 4. These are the only two conditions that we need to check in order to solve this very easily. Let's break this down further. Okay, so give me some possible numbers, right? For example, let's take something like 1, 1, 4, 1, 4, 1, 4, 4, 1, 1, 4. Okay, is this a magic number or not? I say it is. You might say it's not. Let's see whether it is or not. Okay, so this 1 is a magic number. Yes, we can take this out. 14, yeah. 14, yeah. This I can take as 144, and this will be 1, and this will be 14. So regardless of what combination you take here, we've taken so many combinations here. We've taken 114, we have taken 144. All of that still remains magical numbers. What does not remain magical number? Let's say something like 1444. 114. Okay, look, this 114 part, this is a magical number. This part 14 is also a magical number. 144 is also a magical number, but this 4 right here, this is not a magical number. And how do we know whether this particular string has, whether it is or it is not a magical number? This is the only thing that you need to keep in mind. If there are 3 4s together, that means that it's not a magical number. Okay, see, now we have either 1 or 4 for this magical number, and there are multiple combinations on how you can put this 1 or 4. You can do 1. See, any number of 1 will be possible. So 1 is not something that we need to keep in mind, but we need to keep in mind about the number of 4s. Initially, if this 1 4, 4 1 is a case will not be accepted, 41 won't be accepted, but 1 4 will be accepted, 14 is accepted. So that's why this case is there, doesn't start with 4. Okay, that condition we can check. Superb. Then what else? If you're looking for 2 4s, there are different combinations on how you can do it. You can either do 1 4 4, you can do that. You can do 4 1 4. It doesn't start with 4, so that we can reject that. But if there's a 1 before it, we can go ahead and accept it, right? So if there is no 1, this is also rejected. So in 2 4s also we can accept it as long as it doesn't start with 4. This condition is there. Okay, what about 3 4s? Let me take one case like this: 1 4 4 4. Here this is not a magical number, but it does not start with 4. So this condition does not do it. We need to add another condition in this particular case. And let's say 4 4s, 4 4. This condition will be already checked because these 3 4s will already be here with an additional 4. As long as we check no 4 4 4 exists in that particular string, we can say these first two conditions are done. Right? So they can put any permutation or combination they want as long as there is no 3 4s together. That is, for every 2 4s there is one at least breaking in front or behind of it, or this can be 1 4 1 4 also, or 2 4s. That's up to us. This condition is what we're going to check. Once we have checked both of these conditions, I hope you're able to understand why we are doing this. I mean, if you can pause this video right now. Try to think of any case which will break the rule that I've just said. As long as there's no 3 4s together, put any case of these 3 numbers and check whether it's a magical number or not. it will be a magical number. You don't even have to stick to this. You can just randomly put 1 4 1 4 1 4, something like that. As long as these two conditions are there, it will get accepted. Okay, just spend some time thinking about that. Then next case is there should not be any non 1 or 4 numbers in your particular integer. So whether there is, in this case, look, there's 2 and 3, that means definitely it's not a magical number, right? And how do you check that? Simple, you do in operator, that's it. You check if there is any other value than 1 or 4 in that particular string, then you will beat. Okay, so it will look like something like this. Like for I in string, we can take this as a string instead of an integer. For I in string, check if I not in 1 comma 4, that is, it is something other than 1 4. That case we can just go ahead and break and set the answer to be no, right? That's it. So the answer will be yes initially. We'll check for this condition. If this condition fails, we'll set the answer to no. Then we'll go back to the loop. If this condition passes, we will set the answer back to no and we'll break. Finally, we'll just print the answer. I hope you're able to understand how we're approaching this. Let's go ahead and code to see how that looks like. So I've gone ahead and written the logic, whatever we discussed just now. You guys can pause and read through this. Let me just go ahead and put this into new line so that you can read through it a bit better. All of this code is there in the GitHub, by the way. Then what do we do? Let us just take the input as string as we discussed. Then firstly, what do? We set the answer to be yes initial. Then what do? We need to check if the first particular line of that string is 1. If it is not 1, if it is anything else, if it's 4, definitely the answer is no. If it's anything other than 4, also the answer is no, because there's only 1 and 4 can be existing, right? So we check two conditions. First condition will be checking if that first number starts with 1. It has to start with 1. Then there is no 444 in that particular string. How that look like is if st of 0, this particular value is not equal to 1, or check another condition where this string 444 substring, is in string. In both of these cases, the answer will be set to no. Okay, let's put an else part right here. Once we are checking this, right? If this check has gone through, then we do the next checks, right? So we are saying 444 is not there, as well as it starts with 1. In that particular case, see, it starts with 1, 444 not there. Then what we do? Simply check if 1 and 4 are there. If something other than 1 or 4 is there. Okay, how do you do that? Nothing. You do for I in st, right? If I not in, as we discussed, either 1 or 4, you can put this as a string also. It doesn't have to be a list, because that in operator still works if you just put a string of 1 4. That's up to you. So we set the answer to no in this particular case, and then break with this loop as we discussed with that. Done. Then that's it, guys. This is the code. We can actually go ahead and print the answer now. Let me just show you how that works out. You can see all 3 test cases have passed. Let me go ahead and submit this on Codeforces as well. I hope you're able to understand how we're getting that initial logic, that if we have less than 3 4s, it'll be possible. If we have more than 3 4s, it'll be not possible. For that condition only, we're checking with 3 4s. We're not checking with 4 or 5 4s, because if there's any number of 4s which is more than 3 4s will definitely be there in that subsequence. Okay, so you can see the solution got accepted. Thank you so much for watching this video. If this video helped you, hit that like button. If you have any questions, comment that down below. I'll try my best to answer them. If you have any alternative approaches as well, like you can take a stack and you can check for all combinations of 1 4 and 14, you can just 114 and 144, you can check that also. That's up to you. Thank you so much for watching. I'll see you in the next video. Until then, bye.